Part 3 of Exploring Great Lakes Bathymetry with GIS. And now let's turn our attention to the wreck of the Edmund Fitzgerald. As you are learning from your study of lake floors, these lakes are large and deep. They have sadly claimed many ships and the lives of people on those ships over the centuries. Probably the most famous Great Lakes shipwreck of all time occurred in relatively modern times. This was the sad tale of the SS Edmund Fitzgerald, which sank after a number of successful years on 10 November 1975. Here is a tribute to the Edmund Fitzgerald. I took this picture at the Maritime Museum in Duluth, Minnesota. The Edmund Fitzgerald sank at a longitude and latitude of minus 85.11017, 46.998500. That's the longitude and latitude. Use the search tool to search for this shipwreck's location, remembering to put a negative sign because it's west longitude, and add it to your map as a sketch. Zoom to this location. In which lake did this shipwreck occur? Is the shipwreck located in waters over 100 meters deep? Use the measure tool to answer this question. How far is the wreck from the nearest shoreline? Where is the nearest shoreline? USA or Canada? Conduct research on the shipwreck, such as with this source, and speculate on the theories as to why it sank. Which do you find most likely? How could it have sunk despite being so close to shore? What were the final words that the captain sent over the wireless? If you do some research there, it's a bit chilling, I warn you. Here's my photograph of Lake Superior. It can indeed be a dangerous place. I took this photograph in October on the lakeshore on a blustery and rainy day. Lakes are 3D objects after all, and the ArcGIS 3D Scene Viewer might be very useful for further investigation. Examine the same set of bathymetric contours in this 3D scene. How does this 3D visualization affect your understanding of the floors of the Great Lakes? Next, examine this 3D web mapping application showing Lake Superior shipwrecks. Note that here the bathymetric contours are colored differently than the 2D map you were examining up to this point. Can you determine which colors signify the greatest depths? In this 3D scene, note how many ships have been wrecked near where the Edmund Fitzgerald went down. How does this 3D visualization affect your understanding of shipwrecks? Did most of the wrecks occur in the middle of the lake or close to shore? Why do you suppose this is the case? While the wreck was located a few days after the ship sank, using magnetic anomaly detection, shortly thereafter by sonar, and afterward by unstaffed and staffed submersibles, it wasn't until 1995, 20 years later, that a scuba dive resulted in the first people to touch the ship physically since 1975. Examine the table showing the deepest technical scuba dives for shipwrecks around the world in this article. What rank in shipwreck dive depths was the 1995 dive to the Edmund Fitzgerald? Read about this 1995 dive in this article. Why was the dive controversial? Let's narrow your investigation now a bit more. Suppose you have just received word of a new budgetary constraint on your shipwreck project that means you can now only focus on the lake where you found the deepest contours and where you located the above wreck. Return to your original 2D map investigation in ArcGIS Online. You might need to filter on the deepest parts, 100 meters or more again. Again, access the filter tool. Add an expression where the lake name is the lake name that meets both of the above criteria. What does your expression now look like? After running your expression, open the data table again. Now how many records exist in this newly filtered table? What percentage of the original data set, as measured by the number of records, do you now have? If time permits, add data for other Great Lakes shipwrecks, using ArcGIS Online as a starting point. Using mathematical expressions and filtering aids in analysis and decision making. Mathematical expressions can also be used in interactive maps to customize the appearance of the pop-ups, for labeling features, for symbolization, for spatial analysis, and much more. These expressions are simple but powerful. Now consider another way of visualizing Great Lakes bathymetry using a technique that results in an etched woodblock effect from my Esri colleague John Nelson here. So much more could be done with this data, these tools, and this lesson. Create your own question now that has not been asked thus far. Now consider, how could you answer your own question? As a fitting end to your investigation, listen to Gordon Lightfoot's song, Here. Even after hearing the song for the first time as a kid all those years ago, today it still gives me chills. After listening, answer the following questions. What did the native people call Lake Superior? What was the ship's destination that day? What month was the wreck? How many nights did the ship spend on the lake during that final voyage? Where was the memorial service held? How many men died in the shipwreck? Isn't it amazing how much information can be learned even in one song? That's the power of music, folks. And also how much can be learned in one GIS-based investigation. That is the power of GIS, folks. Thanks for being with me. Keep on exploring.